next example, let's look at the differential equation y double prime plus 4y prime plus 29y equals 3x. This is again a second order linear non-homogeneous with constant coefficients. And we're going to do the same thing that we've been doing. Let's find the complementary solution. To do that, we're going to look at the associated homogeneous equation, y double prime plus 4y prime plus 29y equals 0. That's going to lead us to our equation, our characteristic equation r squared plus 4r plus 29 equals 0. And then we need to figure out how do we solve that equation. So we're going to, we want the coefficient, the constant term on the left side of the equation to be plus 4. That's what would make it a square. So we're going to move 25 over on both sides. So subtract 25 from both sides. And we get r. So this tells us that r plus 2 squared is going to be equal to negative 25. And therefore, our solution for r, let's make this a little bit more compact here. But our solution for r is going to be r equals negative 2. So r is going to be equal to negative 2 plus or minus 5i. And therefore, our complementary solution is going to end up being e to the negative 2x times c1 cosine of 5x plus c2 sine of 5x. Okay? And so that's really all we have to do for the complementary solution. Next, we'll look at the particular solution. And for the particular solution, we have to make a guess as to what our particular solution is going to look like. And I think a good first guess is going to be a constant times x, because that's what we have. Except it turns out that it's going to not work. And the reason why it's not going to work is that it turns out what we should have is, the right way to think about this is not as a constant times x, but as a linear polynomial. So we need to put a general linear polynomial as our guess for the particular solution. Okay, it turns out that we will need that plus b. There might be some examples where that b is 0, in which case you could have gotten away with the previous guess. But in general, we'll need the ax and the b as well. So once we have this, the rest of this problem becomes a breeze, because the first derivative is just a, and the second derivative is 0, so it's a linear term. And then if we plug each of those quantities in for y on the left, we're going to end up with, well, the second derivative is just 0. So again, let's call this star. Star is going to become 0 plus 4 times y prime was a, plus 29 times y, which is ax plus b. We want that to be equal to 3x. And remember, when I say that these are equal, I want these to be equal as functions, meaning that I want to know what are the constants a and b, so that no matter what x value you plug in, you always get the same thing on both sides of the equation. So we need to figure out what's the values of a and b that'll make this work. And so there's really two ways that you can do this. I think the easiest way is just to collect all the linear and constant terms on both sides and set them equal. So you end up with 29ax plus 4a plus b equals 3x, and really I'm going to think of this as 3x plus 0. The reason for that is that we're going to compare the corresponding coefficients. So we want 29a to be equal to 3, and we want 4a plus b to be equal to 0. So if we have 29a equals 3, and 4a plus b equals 0. This is a system of two equations and two unknowns, but we don't really have to work that hard. A is going to be 3 over 29. And if a is 3 over 29, then that tells us that b is going to be minus 4a, so that'll be minus 12 over 29. And therefore, our particular solution that we are looking for is ax plus b. So in our case, 3 over 29 times x minus 12 over 29. And then once we have our complementary solution and our particular solution, the general solution is going to be e to the negative 2x times c1 cosine of 5x plus c2 sine of 5x. So that's the complementary solution, plus the particular solution. So plus 3 3x over 29 minus 12 over 29. And there is our general solution to this second order linear non-homogeneous equation.